Now, when it comes to building your kits, planning and organization are key. Packaging is a very important aspect. We found that for packaging small amounts of liquid, these disposable pipettes, you can see it, they actually work really well. Now, usually when you think of a pipette like this, you're just thinking about transferring liquids. But if you cut off the end, you can see this is a bit shorter, you can drop some liquid. And then I actually filled this one with water, but I have another example here. You can draw up the liquid and then use a lighter on the end, and it will melt the plastic, and then that will create a plug, and then the liquid is stored in there. So it's a really great way for small amounts of liquid. These are really inexpensive. You can buy them in bulk. We found that for packaging small amounts of solid, just small baggies work really well. It's a really good idea to package everything for a particular lab together in one bag. We know that kids like to rummage through things, and so if they can just grab what they need for a particular experiment, that's going to decrease some of the inevitable chaos that's going to happen. This is an example here of a lab that has everything together in a nicely labeled bag here. Now, next, one of the skills that we usually want students to learn is how to use a balance. We want them to be able to get good data, record that data, and analyze that data. But as you know, laboratory balances are extremely expensive. We were actually able to find some pretty high quality balances that are very affordable. This one right here, it's by a company called True Way. And if you look online, it's like between $10 and $12. They do have a wholesale option, so you might be able to get a discount if you're buying them in bulk. The particular balance that I showed you, it records all the way to the hundredths place. We've had a lot of success with them in our classes. It might be a good idea also to consider purchasing a classroom set of materials. Companies like Flynn do a really nice job with this. This particular example is an acid-base titration. And what I really like about this one is that students don't need a burette. Burettes are not practical to include in individual kits. And so this lab uses graduated pipettes, and you can get really good results from it even when you're not using a burette. Which brings us to our next topic. How do you choose the labs? Well, if you are an experienced classroom teacher, it's probably a good idea to think about what's already worked for you in the brick and mortar classroom. How can you adapt it for an online setting? If you are a new teacher, welcome to teaching. This is a very interesting time to join the profession. That doesn't mean this still can't be done. It might be a good idea, if you don't have much experience yet, to lean on a more experienced teacher from your school for ideas. Also consider those classroom sets from companies like Flynn. Those labs have been tried over and over again, so they're pretty good. Next, we want to think about our objectives. Oftentimes, teachers and parents put themselves in a box thinking that if a student's going to be doing a lab at home, they have to come up with some creative way of utilizing household chemicals. Well, sometimes that's wonderful because it shows how science relates to real life and your everyday life, but I don't think it's the best starting place. For example, cabbage juice can be used as an indicator for pH. So students can make their own pH indicator using cabbage juice, a blender, and water. They can then test different household products using that indicator, and that's great. I have seen teachers try to take it a step further though, and have students actually complete a whole titration using homemade cabbage juice indicator. Well, the data comes out really, really sloppy, and then students are confused and they don't actually learn the objectives, which is how does a titration work? What is an endpoint? What's an equivalence point? How do they apply the stoichiometry? In that case, it would have been a better idea to just purchase a high quality lab grade indicator for the students. On the flip side, sometimes it's okay not to get great data. And Christina has an example from her class.
Yeah, in our biology class, we do labs in which the students don't always get the expected results. And I think this is important because it allows students to see sometimes where that making the procedures, figuring out what independent variable they want to test, how they're going to test it. It allows them to see some errors in their procedure writing and in their hypotheses. So for example, we oftentimes do a lab in biology in which the students have to demonstrate that the plants are getting their mass from carbon dioxide and water and not from the soil they're being grown in. The students are given a pretty open-ended lab to design, given some basic materials. And so some students get really good data that supports their hypotheses, and some students get really poor data that reject their hypotheses. And this is good for students then to talk about which experiments led to kind of the expected results and which experiments didn't, and why it's important then for students to be able to replicate their investigations, and why scientists go back and redo investigations. They don't always just do it one time and say, yay, I'm done. So again, it sometimes is frustrating for students not to get the expected results, but sometimes it leads to a really good discussion on what real science looks like.
Absolutely. Wouldn't it be nice if life always just gave you the yay? So no matter what, you're going to have to modify a few things, right, when students are working from home. We just talked about using those graduated pipettes instead of a burette. That's a good modification. Another one is using one of these culinary fuel cans instead of a Bunsen burner. These are really nice and easy to use for students. You can see the setup in this picture here. We have an aluminum tin, so that really helps with safety issues, and it also protects the surface underneath. We also provide these smaller aluminum tins, and I have students use these tongs, so they can just pick it up like this and use that to extinguish the flame. Another thing that I like to include in these kits are well plates. Well plates are extremely inexpensive, and they are so versatile. You can see in the picture that one is being used as a test tube holder. So you don't need to send a test tube rack home with students. You can use a paper towel like that, and that's going to hold it in place. Well plates are also really good for small scale reactions because you can use just a tiny bit of reactants and you can see the reaction happening, and you can easily compare from well to well what's going on. Sometimes it does make sense to use household chemicals. So when you're actually going to be able to meet your objective using things around the house, absolutely use that option. One great example that comes to mind is chromatography. Chromatography can be done with coffee filters, isopropyl alcohol, and then just Sharpies, different markers, pens, or even food coloring. So when it's appropriate, absolutely try to use what's around your house.